Okay, you guys, welcome to virtual algebra class. Today we are talking about solving inequalities. In order to understand solving inequalities, I have to make sure that you still remember the difference between an expression and an equation. Do we remember what an expression is versus an equation? So when I think of an expression, I think of it like a single math problem, not necessarily a single operation, but a single problem, because an expression is some combination of numbers, variables, and I hope by now everybody remembers those variables are those symbols that we use to stand in for numbers that we don't know, generally letters, okay? So we have our numbers, we have our variables, and we have our operands, our operations, like add, subtract, multiply, divide. Okay, so for example, here's an algebraic expression. It might look nasty, and I'm not asking you to do this math, so don't panic. But you can see that it's a combination. We've got some numbers going on, 2 and 3. We've got a variable, x, and we've got some operations. We see some multiplication here. I'm raising x to the 4th power. I'm adding. That's that idea of an expression. So does that make sense to everybody?
Yes.
Okay, wonderful. Now remember what an equation was. The day we graduated to the equation, we actually said when we're looking at an equation, we're looking at two expressions that are equivalent, two equivalent expressions. And so we might see 2x to the 4th power plus 3 on one side, but there'll be an equal sign and we'll have another expression on the other side, and it could be anything. And the good news is I'm not going to make you do this math. This, in fact, is well beyond the level of the GED. We won't solve this, but I just want you to see that this is an equation. It has two expressions that are equivalent. And I can tell they're equivalent by my equal sign. Does that make sense?
Yes.
Okay, wonderful. So up till today, we've learned a lot of things. We've learned to simplify expressions in a lot of ways because we know the only thing we can do with an expression is to simplify it, be obedient to the operations that we've seen. And we've learned to solve equations. And that was that work we did to get the letter alone, solve equations. Well, today we're going to start talking about solving inequalities. So the question that we've got to ask ourselves is, what is an inequality? And so I want to let you know that an inequality is super similar to an equation. Even though they're the opposite with the word in, the playing field that we're playing on is really similar. So an inequality is like an equation. It's going to have more than one expression, just like above. But instead of a relationship of equality or equivalence, we have a relationship between the expression of inequality, not equalness. The two sides are in some relationship, but they're not equal. It's a different relationship. So inequality is like not equalness. The two sides are not equal. Now you might be thinking, well, why do we care if the two sides are not equal? Just because they're not equal doesn't mean we know nothing about the way they're related. With an inequality, we know something about the way they're related. There's 4 possible inequalities. So did you guys get this page down? Can I move on?
Yes.
Okay, wonderful. So there are 4 inequality, 4 different relationships you could see between the expressions here. I'm going to just call them inequality symbols. The first two, hopefully you guys are familiar with. Okay, now what I usually, hey Marilee, welcome. The main issue that students usually have when I put these symbols down is not that they don't know that they're the greater than and less than symbols or the less than and greater than symbols. They just don't know which one's which. So it's a really common issue that students don't know how to read them. And I know that a lot of fourth grade teachers teach the alligator method. The alligator opens its mouth to the bigger number. If any of you have learned that, it's super useful. But we definitely need to graduate beyond that for our high school math, because we have to be able to read these like a direct translation of these. And so the way that I will help you guys to remember them is like with a number line. So I want you to imagine I'm going to draw a number line right above this. As we know, when you're on a number line, we learned that in our portion on Odyssey where we looked at negative numbers. As we go off to the left, our numbers get less and less. And as we go off to the right, our numbers get greater, larger and larger. Does that make sense?
Yes.
And if you look at these symbols, they look just like the arrows on the end of a number line. The one that goes off in the less than direction is indeed the less than symbol. So you would read this as less than. So we have a relationship. This time we would have a relationship between at least two expressions, but instead of them being equal, the first one would be less than the second one. Does that make sense?
Yes.
And then similarly, this one is greater than. Okay, so I said there were 4 inequality signs. What else could there be besides less than and greater than? Well, there's also the ones that have the little line underneath. They look almost exactly the same. It still looks like a less than symbol, but it also has a little line underneath. And this one allows for equivalence. We're saying it might be less than or it might be equal to. We call that the less than or equal to. And same thing, we have the same thing with the greater than. It's a greater than symbol with a little line underneath, kind of like an equal sign, and this is the greater than or equal to sign. Okay, so we are going to be now solving, just like we solved equations, we're going to solve inequalities, where we have some expressions that are related to each other in different ways. But before we start solving, I want to look at some of the answers we might get, some of the solutions to make sure that we could make sense of them. So we could solve an inequality and we could get an answer that looks like this. So what am I saying here? Let's read it. It says X is greater than or equal to 7. And so I'm saying it used to be that we had answers that were like this, and I'm going to erase this so you don't need to write it down. But, you know, when we had equations, we would have an answer like that. X is 7. I only have one answer when X is 7. The difference between that and an inequality is now there's a range of numbers that could make my answer true. 7 would work, but so would 8 or 9 or 13 and a half. Does that make sense? Yeah. Anything greater than 7 would be true. And we'll often plot that on a number line. So let's see, let's just look at the portion of our number line where 7 is. So if X is greater than or equal to 7, that would mean it would be okay for it to be 7, or it could be anything larger than that. So I'm going to shade in the the right-hand side of the number line where I get larger, greater, and I'm going to shade in that arrow. So what I'm saying is anything from 7 on is a perfectly acceptable answer. Okay, so let's take a look at some others. You could have X is less than or equal to -5. So same idea if I were thinking about that answer. I said less than or equal to -5. So remember how it works when you do negatives. As we get more and more negative, we're actually getting smaller and smaller. So we're going out further and further to the left. So I didn't really give myself enough space here, but X is less than or equal to -5 means it could be -5 or it could be anything left of that, less than that. Notice that my arrow points in the direction I'm shading. See, when it was pointed left, I shaded left. When it was pointed right, I shaded right. Can you see that? Okay, wonderful. 2 more solutions I want to look at because they throw students. Let's look at something like this. X is greater than 5 halves. Okay, there's two ways we can panic here. First of all, the symbol just greater than, how do we picture that on the number line? Or we could just panic at the 5 halves. So let's take care of the fraction panic first. Okay, so I want to just think about, obviously I'm in the positive, so I'll start at 0, 1, 2, 3. Think about what a fraction means. The numerator of a fraction tells you how many, but the denominator tells you the size of the pieces. So this is telling me to cut everything into half. Everything into half, to count by halves. So if I wanted to do 5 halves, I have to look at the halfway points between each number. Does that make sense?
Mhm.
And 5 halves would be, this would be 1 half between 0 and 1. Now, if I grab another half at 1, this is 2 halves. And now here we have 3 halves, 4 halves, 5 halves puts me squarely between 2 and 3. This is where I'm at. Now notice something about my circle. It might be a little hard to see. My circle is open. It's not shaded in. Can you see that?
Yes.
Yes, it's open because X is strictly greater than. There's no little line underneath, so there's no possibility that it's equal to 5 halves. It's just definitely greater than. So I put an open circle on the 5 halves, and then I still am going to shade in the greater than direction. So I'm going to go off greater than, off to the right, and shade in this arrow. Does that make sense?
Yes.
Okay, great. And now let's do two last ones I want you to see. So then I could have something like X is less than negative 3/4. So again, if 0's here, I get more and more negative as I go left. Where is negative 3.4 going to fall? Well, it's going to be a little less than negative 3, but not quite so much as negative 4. So about somewhere in there. And again, I'm going to put an open circle, and then I'll go off in the less than direction. Left is less. Is that good?
Yes.
Now here's the last weird thing that you could have with an inequality. A number could be between things. Now, we know this happens in real life all the time. Like my GED students are usually between 16 and, I don't know, 70, 16 and 80, but I definitely have a between factor. I have students who are, they're not younger than a certain age, but they're also not older than a certain age. And so you can see that with inequalities. You can see an answer sandwiched between two numbers. So here's an example of that. And this freaks students out. But what am I saying here? I'm saying X is between 4 and 8. 4 is something less than X, but X is less than 8. X ends up sandwiched between 4 and 8. So if I were to look at this on a number line, now, take a look at this relationship between the 4 and the X. Do you notice how the inequality sign here does not have an equal sign? So I'm going to put an open dot on 4. Is that cool?
Uh-huh.
Okay. Now, notice here at the relationship between X and 8, that one is going to have a closed dot because I can see the equal underneath my little less than sign. And so this one will have a closed dot. And if I have X sandwiched between the two of those, that means I'm going to shade in the space between them. See, 4 is smaller than my X, so my X is on the other side of 4, but then my X is smaller than or equal to the 8. Does that make sense?
Yes.
Sweet. So now that we have all the skills we need in our disposal, we can start solving some inequalities. So let's take a look at some of the problems you're going to see on the GED. Hey, welcome back, Bianca. Okay, so let's start with our example problems. I'm going to clear this page. And if anybody has trouble keeping up with my notes, I'll post the video by this afternoon so you could get the rest of your notes. So first thing, well, before I even write example, I'm sorry, I want to tell you the main thing. So the main thing here to know as you solve is that we are solving the inequalities, meaning we're working to get the letter by themselves. which means that the same rules that we used with equations are going to apply to inequalities too. It's not like it's some new land. We're still solving. And so everything we learned in the last video on solving multi-step equations, we still have to use. It's all fair game. Okay, so inequalities are solved. We are working on isolating the letter. So all our rules of solving are still in effect. And we're going to see two new things. There are two new things to do with inequalities, and I will get to those. But first, I want to show you how all our old rules are still in effect. So if you took a look at our last video, then you would know the 3 basic wisdom steps to solving any kind of complicated linear equation, no matter how many steps it has. It's a really good idea to simplify before you start solving. As I explained last week, it's not necessary. Sometimes you can solve before you simplify, but it's a good wisdom principle. We just kind of clean up before we start solving. So we simplify the individual expressions. Then we had to make sure our letters were all on one side. So we would get the variable terms to one side. If we had letters on both sides, we said, how in the world could we ever get the numbers away? Because the letters are everywhere. And then the third and final thing we would do is work on getting that letter alone. And these 3 wisdom principles will take you all the way through about any kind of linear equation you can imagine. So most of the problems on the GED, okay? And they're also going to help us with our inequalities. So let's take a look at the first example I have here. So I know this is an inequality because I see here that I have, in this case, 2 expressions. I have an expression on the left-hand side, 2x minus 7. I have an expression on the right-hand side, 43. And I have a relationship of inequality between them. This one is less than or equal to. And like I said, all the old rules of solving are going to apply. I'll look on just the left-hand side. So I'm looking at just 2x minus 7 and decide if I can simplify. I can't. Look at the right-hand side. There's no work to do over there. I could get the variables to one side, but they're already on one side. So I'm just going to go straight to that third step, isolating the variable, getting the letter alone. And just like always, when I want to get the letter alone, I use the inverse operation. So instead of minusing 7, I'm going to do the opposite of what I was told. I'm going to add 7. And the rule is I can do whatever I want as long as I do it to both sides. Now, even though this is an equation, isn't an equation, it's a relationship, this same principle still holds. So what I said when I said 2x minus 7 is less than or equal to 43 is I'm giving you this kind of relationship here, where one is probably below the other. So if I add 7 to both sides, they each go up by 7. Even though they will have changed, they'll be in the same relationship. The left-hand side will still be less than the right-hand side because they went up by the same amount. Does that make sense?
Yes.
Okay, so as long as that makes sense, then you can agree with me that adding 7 to both sides will be legal. So let's see what happens then. On this side, my minus 7 and my plus 7 will cancel, leaving me with a 2x. I haven't changed my relationship by adding 7, so I'll have that same relationship, and 43 plus 7 is 50. And so I have the new inequality. 2x is less than or equal to 50. Okay, this is not solved yet because the letter's not alone, so I'm working on isolating that variable. 2 and x are shoved up next to each other, meaning they're multiplying. So in order to get rid of 2, I will divide. And I'm going to do that to both sides. Be really careful. Some students have the really bad habit of writing the x under there. I'm not taking the x away. I'm leaving the x. I'm just moving the 2 away. Okay, so on this, what's going to happen now that I've made that balance change? On this side, I'll have my x, and on this side, I'll have my 25. Again, if they were in this relationship and I just half both of them, one will still be less than the other if I just half them. And so I can do that to both sides. And there is my final answer. X is less than or equal to 25. They may ask you on the GED, they say they will, although I've seen lots of practice problems where they don't. But in the list of things they ask you to do, they say that you might have to graph your answer on a number line. So let's decide. The first thing you need to decide is, do I need an open or closed dot?
Closed.
Exactly. I'm going to use a closed dot because of that equal line underneath my less than sign. So I'll use a closed dot on 25. And then the second thing you're going to need to decide is, what direction do I go in?
The less than direction.
Exactly. Less than direction, or left. We can see that arrow points off in that less than direction. X is less than 25. And so all the numbers underneath 25 are fair game. Okay, very simple example of solving an inequality. May they be that simple when you take your GED? I hope they are, but they might not be. So let's graduate to a little more complicated, okay? We good with this screen?
Yep.
Okay. My example 2, 5x plus 1 minus 3 is greater than or equal to negative 22. So once again, this is very similar to what we did last time. We can see that this is a multi-step equation to solve. And we can see here that there's some simplifying I can do before I solve. I am actually taking my hand and covering up the entire right-hand side of the inequality. And I see on that left-hand side, 5x plus 1 minus 3, there is work I can do. I know how to take 1 and subtract 3. It's straightforward work. It's on the same side of the equation. Just go ahead and do that math. So 1 minus 3, if I only have 1 and I take away 3 from that, I'm going to end up in the negatives. I'm going to be negative 2. And again, you would have your GED calculator. So if you struggle with adding and subtracting integers, you could have done that in your calculator. 1 minus 3 would have given you negative 2. And that left-hand side is greater than or equal to negative 22. I'm not going to touch the right-hand side when I'm simplifying. Does that make sense?
Yes.
Great. And now it's just a two-step equation to solve. So I am going to be disobedient. Instead of subtracting 2, I'm going to add 2. Because I'm the one making the change, I do it to both sides. And I see what my new inequality is. So negative 2 and positive 2 cancel, leaving me with just 5x. And that is going to be greater than or equal to, if I had negative 22 and then I went up by 2, I would only be at negative 20 now. Great, I'm almost done. My letter's almost alone. I'm just going to divide away that coefficient of 5. On this side, 5 and 5 cancel, leaving me with x, and x is going to be greater than or equal to negative 4. Again, we've not yet seen a difference between solving inequalities and solving equations. This seems to be exactly like it is in the land of equations, just like what we did last class. So I'm going to do one more like this, and then we'll look at a couple of differences when it gets tricky. Okay. Am I good to erase this problem?
Yes.
Great. So third example I wanted to look at. 4 times the quantity, x minus 3, is greater than x minus 8 plus x. Ooh, I just realized I forgot to graph my last answer, guys. Sorry about that. But I'm just going to forge ahead here, do this one, and graph this one. So take a look at this problem here. You can see that there's a lot more going on in this one, but it is just like a multi-step equation. I have an expression on the left. I got an expression on the right. A good rule of thumb is to simplify before you solve. So look on the left-hand side, just the left-hand side. Is there any work we know how to do there?
No.
What was that?
No.
So Heather, go back and watch my distribution video. Okay. Bianca, did you get a chance to watch the distribution video? Do you know how to multiply in algebra class? Wonderful. So you can see here, this 4, do you see how it's shoved up against the parentheses? We can always multiply. Adding and subtracting we can't always do, but multiplying we can always do. The important thing just to know is that multiplication, yes, which means multiplication passes out to everything in the parentheses. So I'm going to multiply my 4 times x. 4 times x is just 4x. And I'm going to multiply my 4 times negative 3. 4 times negative 3 is negative 12. And so that was some simplifying I could do. Is everybody cool with that?
Yes.
Yeah, don't feel bad, Heather. There's a lot of stuff going on in algebra. There really is. And if anybody who's watching, because I promise you're not alone, needs a reminder of what I just did, that's the distribution video. Okay, so 4x minus 12. Now I look on the right-hand side. There's also some simplifying I can do over there, but it's not distribution. There's no multiplying. I don't see any parentheses. What can I do on the right-hand side? Can you guys see it? Heather's like, I learned not to answer. I'm not answering anymore. Yeah, so good job, Bianca. Bianca said she sees that I could put those X's together. Absolutely. The X and the X over here are what we call like terms. They're the same kind of thing, so they can be combined. And so that's the combining like terms video if you need that. It's real hard if you missed a lesson in algebra class because everything builds on itself, okay? But if I have an X and an X, remember that if you just have an X by itself, whatever he is, there's just one of him. That's just one X. And this is another X over here. It's like if I had an apple and an apple, I'd end up with two apples. So if I have an X and an X, I have a total of two X's. Is everybody cool with that?
Yeah.
Now, there's nothing to combine the -8 with, so the -8 would just drop. Whenever we're combining like terms, we put the things that are the same kinds together, and then the other things we just leave them be. We can't put them together, but we'll just leave them. Okay, so now I simplified my left and right-hand side. You can see I did that first step, simplify the expressions. That was my first thing I said you should get about doing when you are solving multi-step equations, or in this case, inequalities. The rules are the same. Okay, now the second step I said, though, was you better get your variable terms to the same side. We didn't have that happen on the last two problems, but look at this problem. Look at it. Can you see that there's an X in the left expression and there's an X in the right expression? Yeah, we can't handle that. How are we supposed to get the numbers away from the letters if the letters are everywhere? We have got to get the letters over to one side, and then we can take all the numbers away. And so that's got to be your next step. You've got to move one of these letters. And I wanted to do this problem with you because when we were doing equations, I said it doesn't really matter what side you move the letters to. But when we're doing inequalities, in the end, you're going to want to get the letter to the left anyway, so that we can see it properly on a number line. So a good wisdom principle is put the letters to the left. Again, it's not necessary. There's always more than one way to do things in math class. It's just I've found that students make less errors when they just get the letters to the left from the beginning. And so that's my wisdom principle for you, okay? If you don't follow my wisdom, you can still get a right answer. Okay, it just gets a little trickier. So I am going to take this entire 2x away. Yes, and notice that I'm doing it through subtraction. A lot of students try to divide because they're used to when I break the 2 and the x up, I have to divide, but I'm not breaking up the 2 and the x. I'm taking the entire term and I want it to zero out. I want it to move away. And so I'm going to subtract that 2x away. Okay, and then I'm going to, oh, I should have done it in my different color to be consistent. Okay. Now the rule of algebra is I can do whatever I want as long as I do it to both sides. Exactly. And I'm going to write that right underneath the 4x, as Bianca pointed out, so that my like terms are right under each other so I don't screw up. Okay. So now let's see what our inequality looks like after we make this change. We take 2x away from both sides. So on this side, if I took 4x and I took away 2x's, I'd have 2x's left. Just like if I had 4 apples and I took away 2 apples, I'd have 2 apples left. Okay, my x part doesn't change. I'm just counting up x's. I haven't touched my -12, so it'll still be there. I'll still have my greater than sign. And on this side, my 2x and -2x will cancel, and the only thing left will be -8. And now we can see we got the variable terms to one side. Now's the time to start isolating that variable. You can get that letter alone now. And this will work just like it's been working, so I'll go through this pretty quickly. I'll use the opposite order of operations, so I'll move anything that's adding or subtracting first when I'm solving. My new inequality will be 2x is greater than 4. And now I'll break up the 2 and the x. I'm just moving the 2, so it is division. And so I'll have x is greater than 2. How do we feel about that, ladies?
Okay.
Like, she started going fast. That was rude. I do want to just, like I said, you won't always have to graph it on the GED. I see not that many examples where you do, but just in case they ask you to graph your answer on a number line, which is common, and it's common in math classes too. I want you to know how to do it. So this says x is greater than 2. Notice it's strictly greater. There's no little line underneath, so I'm going to have an open circle. And then I'm going to go off in the greater direction. And it's not necessarily necessary that your open circle is that big, but I just wanted you to see that that circle was hollow, open. Okay. Wonderful. Okay, so as of right now, people be like, Kate, why do we have to have a new lesson on this? This is all the same stuff we've been doing. Inequalities don't seem any different than equations. What's the difference? So let's look at 2 weird things that happen with inequalities that never did happen with equations. Okay, so here's where it gets funky. So the first thing that I want to warn you, this is my new idea 1 that comes with inequalities. And that is an inequality doesn't have to be a relationship between 2 expressions. We can actually see more expressions. An inequality can be a relationship between 3 expressions. Now, as it turns out, it's not hard to deal with this, but you just have to be aware that that's what you're doing. Sometimes when I get really excited, I yell. Do I sound really loud to you guys?
Yeah.
Okay, good. Sometimes I give myself a headache. I leave class after teaching math for 3 hours and I have such a bad headache. I'm like, if this is how I feel, how are my poor students doing? I think they must bring Excedrin in their backpacks. Okay, so let me show you my first example of this. Okay, on this problem, unlike the other ones I've seen, I don't have a relationship between only 2 expressions. I actually have a relationship between 3 expressions. Now, they're not complicated. The first expression is just that 31. Can you see that on the left? I have just 31. And then I have in the middle 4y plus 7. There's another expression. And then I have on the right 51. That's another expression. It's a simple little expression. It's just a number, but it still is 3 expressions that are related to each other. Can you guys all see that there's actually 3 expressions here?
Yes.
Can you visualize that? I just need you to visualize that. Okay, so the rule of equations was always I could do whatever I wanted. I extended that to the inequalities. You can do whatever you want as long as you do it too. I kept saying both sides, both sides. But here, if I say both sides, the deal is I've got 3 things in relationship. I have 31. That's less than or equal to 4x plus 7. That's less than or equal to 51. We have 3 things in relationship. So that means that whatever I do, I have to do to all 3 expressions, and that's the only new change here, that I might do the same thing 3 times, okay? But I'm still working on getting the letter alone. So use your colors if you need to. Yeah, Bianca's already done the work. Cool, I haven't done it yet, Bianca, you might be right. But this is the place where y is. That's the expression where y is. So I'm going to work to isolate y. So there's 2 things I have to get rid of, a plus 7 and a times 4. Does that make sense? So that y can be alone. Okay, so the first thing I'm going to do is subtract 7. Again, I'm working to get y alone. Now the rule of the rule of equations and inequalities are the same. Whatever you do to one expression, you have to do to all the expressions. So I'm going to come over here. I'm going to subtract 7 here, and I'm going to subtract 7 there. There's 3 expressions, so all 3 get 7 taken away. Does that make sense?
Yes.
Okay, cool. That's the only change. Oh, isn't it brilliant, Bianca? Bianca said, oh, with all these H's. Yeah, exactly. And that's it. That's the only difference here. So let's see what happens when we do that. So if I have 31 and I take away 7, I think I'll end up with 24, but it is morning time. So y'all ladies stop me if I get it wrong. And then in this middle expression, if I add and subtract 7, those will cancel out. So the only thing I have left is that 4y. Then I'll have my same relationship is less than or equal to, and 51 minus 7 will give me 44. How's that looking to everybody? Is that cool?
Yep.
Okay. So I'm almost done. Y is almost alone, but I see that I have another number I have to get rid of. This 4 is hanging out with Y. It's multiplying, so I'll do the opposite. I'm going to divide by 4. Is everybody cool with that? I'm not subtracting 44 because 44 is not with Y, Bianca. So you have to move whatever number is with Y and take it away. Does that make sense? Okay, it's not about, oh, okay. So it's not about which number, I'm going to just do this in a different color. It's not about which number is on the right or the left. My goal right now is to isolate Y, to get Y alone. So I can see that the number that's with Y is 4. Can you see that?
Mm-hmm.
Good. So 4 is the number I have to get rid of. So I'm going to write 4 down here. Now, how am I going to get rid of him? I'm going to do the opposite of what's happening. This 4 and this Y are multiplying, so I'm going to divide. And then whatever I do it to all 3 sides. Now, Bianca, could I have subtracted 44 from all 3 sides? I could have, but it wouldn't have helped me because that would have given my Y more numbers instead of less numbers. So it's like you can do whatever you want, but some things will make the problem uglier. I'm trying to get Y alone, so. Okay. The 3 part. Oh, yeah, just doing 3 in a row. I'll do one more example like this. So we'll do one more. So if it's still throwing you after that, then let me know because I can do even more, okay? Bianca's feeling confused by the 3 parts. Okay, so I wanted to divide this Y by 4, so I do it to all 3 sides, and now let's see what happens. 24 divided by 4 is 6. I didn't change my relationship. 4 divided by 4 cancels, which is what I wanted. I wanted this cancellation. That's why I divided by 4, so that my Y is alone. And on this side, 44 divided by 4 is 11. Okay, so now I have this relationship of Y where I'm saying Y is between the numbers 6 and 11. So let's bust that out. 6, 7, 8, 9, 10, 11, 12. So I can see between 6 and Y, I have a less than or equal to sign. So on 6, I'm going to have a closed dot because I have the equal to part. And then I can see between Y and 11, I have a less than or equal to sign. Again, it has the equal to, so I'm going to have a closed dot. And then see how Y is sandwiched between them? 6 is smaller than Y. Y is my dark line, but Y is less than or equal to 11. So Y could be anywhere from 6 to 11 or anything in between. Okay, that one's tricky. Shall we do one more?
Yeah.
Okay, so students send me these questions on the internet all the time. How do you solve things like this? So I've gotten this one so many times it's ridiculous. So my guess is it's either something like this, and it's not the exact same problem. I changed the numbers, okay? But this same format, I've gotten a lot of times. So I'm guessing it's either on the practice test or it's on the GED itself, because I don't know why else I'd see this exact kind of problem so many times. So let's take a look here. So this is my 5th example for you, and it freaks students out because it looks so gross, but it's actually not that hard. So it says 80, and that is by itself. Now I see a less than symbol, so 80 is just my first expression. And then I see this gross thing, R plus 88 plus 72 all over 3. And that's my middle expression, and it's a little gross. And then that whole thing is less than or equal to 90. Okay, Bianca, I'm going to lead you through this because I really want to make sure you understand, okay? So, can you see here that there are 3 expressions in between each of the inequality symbols? So I have an expression here on the left, an expression here, and an expression there. Bianca says yes. Good. Next thing. Can you tell me which one of those expressions contains the variable, the letter? The middle expression, exactly. So that middle is where that letter is going to stay. We want the letter in the middle, and we're going to move all the numbers away from that letter. Okay, so every other number that's in the middle, you can see there's some numbers in the middle. There's this, there's this, there's this. Whoa, hold on one second, ladies. I just had an issue. I'm going to have to edit that out of the video. My Apple Pen just like died on me. Okay, and you can see what the other number is in the middle. It's that divide by 3, okay? Sorry, my pen just freaked out, so I'm trying to charge it a little bit. But this is the third thing. Now, Bianca said, so add the top first. Bianca, I love that wisdom. That's really good wisdom. We said we could do any simplifying we know how to do before we start solving. That's exactly where a wise student would start. Bianca noticed that 88 and 72 will add, so why don't I add them? So let's start by doing exactly that. So we'll see no other changes except for adding 88 and 72. What do you get when you add 88 and 72? Let's see, 150, 160. So now I'll have r plus 160. The whole thing is still over 3 because I haven't dealt with it, and it's less than or equal to 90 because I haven't dealt with that. So this is what Bianca asked me to do, add the top first, and that is what I did. Is everybody cool with that? Heather, are you okay with that?
Yeah.
Okay, cool. So now, though, there's not really any more simplifying for me to do. I can't add the R and the, I can't add the R and the 160, Bianca, because they're not like terms. I don't want to do this division because I don't want to try to divide R by 3. It's just gross. And so now I'm going to work on getting the R by itself. Okay? In order to get the R by itself, I have to get rid of a plus 160 and a divide by 3. Those are the 2 things that have to go so R can be alone. Okay? The only question is what order do I do it in? So we had said, oh, that's cool. So we had said that when we're solving, we're working our order of operations backwards, which means groups are going to stay together the longest. So when we simplify, we work our order of operations that way. We deal with groupings first. But when we solve, we're going to work our order of operations backwards. We're going to leave our groupings for the very last. So I am going to leave, this is a group, R plus 160 up top. I'm going to leave that alone for right now, and I'm going to get rid of the divide by 3. I'm going to do that by doing the opposite. The opposite of dividing by 3 is multiplying by 3. So I'm going to take this entire middle expression and multiply by 3. Does everybody understand why I just chose to multiply by 3 before I move on?
Because it's the opposite of dividing it.
Yeah, I want to get rid of that fraction. I friggin' hate that fraction, but I know that one way to think about that fraction is dividing by 3. So I'm just going to multiply by 3, do the opposite. Is that cool? Now the rule of equations and inequalities is I can do whatever I want, literally whatever I want, as long as I do it to all the expressions. And so there are 3 expressions here, and so I will take all 3 of them and multiply them all by 3. Is everybody okay with that?
Yep.
Now let's see what happens. What happens when I multiply by 3? Well, when I take 80 and multiply by 3, I end up with 24 with a 0 on its butt, 240. In the middle here, you know what, I'm going to move this down a little bit so my students who have trouble visualizing don't panic when it gets all squished together. Okay. In the middle here, multiplying by 3 and dividing by 3 cancel. If that 3 didn't go away, you did something wrong. All I have left is my R plus 160. Look at that. I got rid of a fraction. The power you always wish you had since 3rd grade, you have with equations and inequalities. And on the right-hand side, 90 times 3 would give me 270. Okay, is everybody cool with that?
Mm-hmm.
Okay, R is almost alone. He's almost alone, but there's still one number over there with R. What number is still hanging out with R?
160.
Exactly. So that's the one I have to move. Don't move the 240. Don't move the 270. They're not hanging out with R. Move the 160, and I'm going to subtract him because that's the opposite of what he's doing. And I can do that as long as I do it to all the expressions, all three in this case. Okay. Now, after I make that change to all three sides, let's see what happens. On this side, 240 minus 160 gives me 80. On this side, adding 160, or I shouldn't say side, in the middle, adding 160 and subtracting 160 cancel so that my R is alone just like I wanted. I'll keep this symbol here that I had. It's the same symbol. And 270 minus 160, was that 110?
Yep.
And so what I just learned is that 80 is smaller than R, or if you think about it, if you want to talk about R, then R is bigger than 80. And R has to be less than or equal to 110. So in other words, R is between 80 and 110. So I think I'll do 70, 80, 90, 100, 110, 120. So 80 is strictly less than R, so we'll have an open dot. 110 now is, we have that less than or equal to sign, and R is somewhere in the middle of those two. Everybody okay?
Yep.
Are you better with the three sides now, Bianca? Good, because they love to put this on the GED. They know we panic. Cool. So same principles we've been following, just if there's three expressions, you're going to have to do your math to all three expressions. Great. So that's one trick of inequalities. Here's the second trick, and this is the big deal one. So if you stop listening to me already, you're like sick of my examples, this woman never shuts up, now's the time to pay back attention, because this will probably definitely be on the GED. This is the big deal, new concept that comes with inequalities. So here's my new idea too. And that is negating both sides. And don't worry, I'll explain myself, but let me just write it down first. I'm going to, instead of saying both sides, since we've already seen it can be three-sided, I'm going to say negating the expressions. Negating the expressions can flip the relationship. I'm going to show you what I mean before I use this principle to solve. So let me show you what I mean first and prove to you this is true with a little statement I think we can all agree on. No X's, no letters, no algebra, but would you agree with me that 3 is less than 5? Does that make sense, everybody? 3 is less than 5.
Yep.
Okay. One way I could prove that to myself, yeah, Bianca says yeah. One way I could prove that to myself is I could put them on a number line. I see 3 over here. I see 5 over there. Of course, 3 is on the left. 3 is less than 5. Now, what I'm proposing is that there's something I could do to both sides of this inequality, because it's just two expressions, but there is something I could do to both sides of this inequality to flip the relationship, to take it from 3 is less than 5 to flipping the relationship. And that would be negating both sides. Exactly, Bianca, brilliant. Bianca said, make them negatives. Exactly. Imagine if they were both negative. Is it true that negative 3 is less than 5? I don't know. Let's look at it on a number line. Yeah, Bianca says, no. I remember that from my Odyssey where. Exactly. Because we know that, let me make my number line a little longer so you can see it. As you go left, you get more and more negative. And we know left is the less than direction. If I had negative 3 here and negative 5 there, well, negative 3 is on the right-hand side, so negative 3 is actually greater. And so I have the wrong symbol. It's not true that negative 3 is less than 5. I would have to flip the relationship if I changed the signs. It would flip the relationship if I change the signs of both sides. Does that make sense to you, ladies?
Yes.
Yes. If that makes sense, then this rule is going to make sense. The one thing that could change an inequality relationship is negating. And we negate both sides. We change their signs when we multiply or divide by a negative. So give this to yourself in really good notes. Highlight this, circle this, underline this. You cannot emphasize this enough. The big idea here is if you multiply or divide by a negative, you have got to flip your inequality sign because you've just flipped the relationship because you just negated both sides. This never happens when you add or subtract, but it can happen when you multiply or divide by a negative. Okay, so now that I understand this, let's go ahead and do some of the trickiest examples you might see on your GED with solving inequalities. Did everybody get this page down?
Yes.
Okay. Okay. My example 6, I have 17 minus 3x is less than or equal to 26. So a lot of students look at this, they're like, it's just a little simple two-step inequality. It must be just like a little simple two-step equation. And almost, but look at what happens, okay? Now there's two numbers hanging out with x that I need to get rid of. There's a 17 and there's a -3 or a -3. Which one am I going to get rid of first? Well, remember, we work our order of operations backwards when we're solving. So we're going to move anything that's adding or subtracting first. So this 17 is adding or subtracting. It's a term with the x. So I'm going to take the 17 away first, -17. Everybody cool with that? We did this back in solving two-step equations. Does that work?
Yes.
Okay. The rule is I can do whatever I want to an equation or an inequality as long as I do it to both sides. So if I have this relationship of less than this and I take the same amount away from both sides, we'll be in the same relationship because I went down by the same amount on both sides. So even though I made a change, I will not see a change in my inequality sign. My relationship between my two sides, if I go down by 17 on both sides, will stay the same. I just subtracted 17. So my sign did not flip. Does that make sense?
Yep.
Okay. But now, I got to get x alone. There's a number I got to get rid of. It's -3. But what is that -3 doing with x?
Multiplying.
Exactly. It's all shoved up against x, all tight like that. You know when two things are all shoved up tight like that with nothing in between them, they're multiplying. And so I am going to have to divide by that -3. The rule of inequalities and equations is I can do whatever I want as long as I do it to both sides. So I come over here, divide by -3. Okay. Now, on this side, multiplying and dividing by -3 will cancel, of course, leaving me with just x. And on the right-hand side, 9 divided by -3 is -3. And you can feel free to do that in a calculator if you don't believe me. But notice that I divided by a negative. Whenever you multiply or divide by a negative, you are going to flip both sides' signs. I'm going to say that again. Whenever you multiply or divide by a negative, it flips both sides' signs. You just negated both sides, whether you realized it or not. And so you are going to have to flip your inequality symbol. You just flipped the relationship. And so I will change it from a less than sign to a greater than sign. Okay, but it was equal before. It'll still have that equality. That part won't change. But if it was greater than, it'll become less than. If it was less than, it will become greater than. Does that make sense?
Yes.
Cool. And this is really as nasty as it gets. So let's put this together with it being multi-step and see how we do. I'm going to erase this page, and I got 2 more examples for you, and then we'll be done. Lucky thanks, because I think I'm talking a lot today. So let's try example 7. 3 minus 2n minus 4 is greater than or equal to -1. I just wanted to bust out an inequality that has a lot of steps, like our equations the other day had a lot of steps. So taking a look at this, I definitely see some simplifying I can do on the left-hand side. So I'm going to simplify before I solve. The first thing I notice is that there's some multiplication. This -2 is shoved up against this parentheses, meaning that -2 is multiplying by everything in the parentheses. I'm going to do that math. -2 times n is -2n. And -2 times -4, notice -2 times -4 is +8. Whenever you multiply by a negative, it changes signs. Okay. Now I'll drop down whatever I haven't used up. My 3 will drop, my greater than will drop, my -1 will drop. Now you might say, Kate, I just multiplied by a -2. Why didn't I flip the sign? That'd be a really good question. Okay, you didn't multiply both sides by -2 and make a change. That -2 was already in that problem. You just did it. It was on that one side. So you only flip it when it's you multiplying both sides by -2 or dividing both sides by negative. Does that make sense?
Yes.
Okay, cool. So when simplifying, you never flip the sign. When solving, it can happen. Okay, so cool. I still have some more simplification I can do on the left-hand side because I see some like terms. I see a plain old 3 and a plain old 8. They're on the same side of the equation, or the inequality. I can put them together like I always have. So I think I'll write my -2n first. I just dropped my -2n, and then I'll add my 8 and my 3 will be a +11. And that's greater than -1. Okay, all I did was combine my 8 and my 3. And now I can see that I do now have a two-step equation to solve. I'm working to get my letter alone. It's only on one side, so I can just start moving the numbers away. First, I'll move anything that's adding or subtracting. My new inequality is -2n is greater than, well, -1 minus 11 is -12. Now I have to break up the -2 and the n. They are currently multiplying because they're all shoved together like that. So I'll divide by -2 on both sides. On the left-hand side, multiplying and dividing by -2 will cancel, leaving me with just an n. On the right-hand side, -12 divided by -2 is 6. And then now, should I flip my sign or not? Well, I just divided by a negative number.
Yes.
Exactly. Anytime you multiply or divide by a negative number, you flip the sign, you negate something. And so I must flip my inequality as well. And so what was a greater than symbol will become a less than symbol. And I should have graphed my last one. I love to forget to do that, but I'll graph this one. So if I have, let's see, 5, 6, 7. If n is strictly less than 6, I'll put an open dot on n and go off in the less than direction now. I've changed my direction. Whew, nasty. You doing okay?
Yeah.
Good. I got my nastiest one. Okay. So if you manage to get through all of these, you shouldn't cry at this one either. I think you'll be okay. And let's take a look.
3 hours of sleep, so I figure that's pretty good.
Anytime somebody doesn't cry in algebra class, I think I've done a stellar job. I'm like, yeah, I sure can teach. Okay, so here we go. Example 8. 20 minus 2p. So before I was a GED teacher, I used to work with adults with disabilities, tutor them in all kinds of subjects. And I had one student with really, really severe dyslexia that I tutored math in. And he didn't cry because he had anger issues, but he would get so mad at me when we were doing math that this vein would come pulsing out on his forehead. And he'd tell me, Kate, I'm going to go take a walk. I was like, okay. Anyway, he did pass his GED, by the way.
Like child, so I get it.
But he took a lot of walks.
Yeah.
Okay, here's my grossest problem. So if you need to cry or take a walk, just pause the video. Otherwise, let's give it a try. Okay. So as always, I want to look at any simplifying I can do on the left or the right-hand side. And if I were your tutor right now, I would pick up a piece of paper and I would block off the whole right-hand side. You know, I would just like literally just block that off right there. So you could just look at the left. And I would ask you, is there any simplifying I can do over there? I could see the only thing I could possibly do is subtract, but those aren't like terms. So they won't subtract. So nothing I can do. And then I would take a piece of paper and I would block out the whole left-hand side. And I would ask you, is there any simplifying I can do over there? And you can see over there, do you see that multiplication, Heather?
Yes.
Yeah, see how that -2 is all shoved up against that parentheses? I can always pass out my multiplication, regardless of what I'm passing it out to. So I will start with that. That's what I see. I see this -2 shoved up against the parentheses. I know that's an act of multiplication I can do, so let's do it. -2 times p is -2p. And -2 times +2 is -4. Notice that when I'm multiplying, I refer to those pluses and minuses as negative and positive. When I'm adding and subtracting, I refer to them as plus and minus. You say, which one are they? I'm like, both. Yes. It depends if I'm multiplying or if I'm adding and subtracting. Okay, so we did that. And now we're going to let everything drop that we haven't used. So we haven't touched our left-hand side. And we haven't touched our plus 4p. Okay, just because you simplified some doesn't mean you're done simplifying. There is some more simplifying I can do here. After you multiply, you distribute, you should look to see if there's anything you can combine, anything you could add or subtract. And indeed, I see some like terms here. I see some p's and some more p's. P's and p's are like, they go together. Okay, so if I have -2p and +4p, we're on the same side of the, we're in the same expression, so we're going to obey the symbols. So -2p and +4p would give me a +2p. Are you cool with that?
Mm-hmm.
I'm not making a change, I'm just combining. And now I'm going to drop down everything from above I haven't used yet. I haven't used my -4, I haven't used my touched my symbol, and I haven't touched my left-hand side, so it'll just still be there. Now I can see that before I start solving, I mean, there's no more simplifying to do, but I can't start solving. I can't start getting the letters alone because the letters are everywhere. See how I have a letter on both the left-hand side and the right-hand side of the equation? Or the inequality? Can you see the letters on both sides?
Mm-hmm.
Yeah, I've got to deal with that first. I can't get the numbers away until the letters pick a side. And so I'm going to move this entire 2p. Remember that when you move an entire term, you have to do it through addition or subtraction. I'm subtracting because I want this positive 2p to zero out. The rule is I can do whatever I want as long as I do it to both sides. So I'm going to write the exact same thing, -2p, right under the other p term. Okay, I made a change, but I made it to both sides, so it's okay. We good with that?
Yeah.
And I chose to move that one so I could get the letters to the left. Okay, so let's see what happens. If I have -2p and I subtract another 2p, I'm going to have -4p. But I won't forget my 20 from up above. I haven't made any changes to that, so it's still there. I'll drop my greater than sign, and then on this side, 2p, -2p, zero out for sure, but I still have that -4. I can't just drop it. Okay?
Mm-hmm.
Cool. Now, my p's have picked a side. They're all over on the left. So now I can move my other things on the right. So I want to get p alone. So the first thing I'm going to take away is that 20, because that 20 is currently a term. It's adding or subtracting with p. Take that away on both sides. And I better follow my own convention. When I make a change, I've been making it pink. Okay, 20 minus 20 zeros out, but I still have my -4p. I still have my symbol, and -4 minus 20 is -24. You cool with that part, Miss Heather?
Yes.
Great. Now I just have to break up -4 and p. And as we can see, they're currently multiplying. They're all shoved up together. So I'm going to have to divide by -4. And whenever you multiply or divide by a negative, that should set off the alarm bells in your head. I just divided by a -4. I just negated both sides of my equation. And so, yes, I'll have a p on the left, And yes, I'll have 6 on the right, but my symbol will flip. It'll go from greater than to less than. And so I have P is less than 6. Did I have P is less than 6 on the last problem too? It's like 6 is my favorite number.
Oh, yeah, it is.
Okay, so then you already know how to graph P is less than 6, but I'll just do it one more time. So on a number line, I would put this open dot on 6, and I would go off in the less than direction. Gorgeous. Okay, that's as nasty as I got for inequalities. So do you have any questions about that?
No.
No. So I'm going to end this video. I'll post it up for everybody, and I will put a practice thing. If you want to practice solving inequalities, you should definitely do so, because it's always easy when the math teacher does it. You got to see if you can make the numbers behave when you're doing the work. Okay. And then let me know if you have any questions. Okay.
Okay.
Awesome. Thank you.
Thank you.